guys, welcome back to the channel. This is going to be video number 3 of the hopefully only 3-part little series that I'm putting together for Automotive and Powersports basic wiring. Today we're going to kind of go over switches, fuses, relays, when you use them, when you don't need them, all that good stuff. So like I said, this is video number 3. If you've missed the first 2 videos, that's fine. You can go back and watch them after this. They don't necessarily go in any sort of an order. So you haven't missed, I mean, you've missed something, but you're not behind just yet by not watching them. So like I said, we're going to start out here with fusing. Get a lot of questions on fuses. And I think everybody understands the basic concept of why you need fuses, but they don't necessarily understand where you need to put them. First thing to keep in mind is your fuses are not necessarily made to protect the piece of equipment that you're hooking up. The fusing is there primarily to protect the wiring from damage in the event of a short circuit. So you always want to put your fuse as close to the source of power as you can get it. So say you're hooking up an amplifier in a vehicle and you have that big power wire that runs back to the amplifier. That fuse for that amplifier, for the wiring for the amplifier, needs to be within 18 inches of the battery. If you're tying onto an existing circuit that requires fusing, then you want to be as close as possible to where you splice in with a fuse. As far as what style of fuse to use, there's a big selection. I mean, you've got your normal little plastic ATC fuses. You can get the bigger maxi fuses. And then, I mean, there's a ton of different fuses. You just have to choose what's appropriate for your application. As far as when you don't need fusing, let's say, and this will make a little bit more sense further into the video, but let's say you're tying into an existing accessory circuit in the vehicle to trigger a relay. Whether or not you need a fuse on that trigger wire is going to kind of depend on a few things. First, is that a factory accessory wire that you're tying into for your signal? If it is, more than likely, well, if it is, then that's going to be fused from the factory. I always recommend tying into a factory wire. That way you know that that wire that you're tying into is protected. Now, all you're doing is triggering a relay with it, so it's not really adding any significant amount of current draw into the system, so you shouldn't have to worry about, you know, whether or not you're going to blow that fuse that's on that wire from drawing too much current through it. Now, if you're tying in with a similarly sized wire, then you don't necessarily need to add a fuse onto it because that circuit's already protected with a factory fuse. However, if you were tying onto a larger gauge main wire in the system with a small wire just to use as a trigger, then you need to add a fuse onto it because that fuse that's in the factory circuit is meant to protect the larger gauge wire, not that small wire that you're tying on. A good example of this would be if you're tying onto the main ignition harness on some of your older vehicles. Heck, those things are fused at 40 amps quite a bit. If you're tying an itty bitty wire onto it, if that wire ever shorts out, it's going to burn up that wire long before it ever blows that 40 amp fuse. So that would be an instance where you would want to fuse a wire like that. All of your other wires that are coming from a main power source that have a significant current draw on them definitely need to be fused. So, moving on. I mentioned the wire size. Wires are usually, well, they should be, they're measured by a gauge. And the gauge has to do with the circumference of the wire and its ability to let electrons flow through it, yada, yada, yada. You need to size your wire according to your load. I'm not going to go over all of that, but there are charts available online that will help you figure out what size wire you need for the current draw of your load. Pay attention to them because the longer the run of wire, the larger the wire that you need. And you have to factor in the whole length of the wire. You can't sit there and go, well, I took a tape measure along the side of the vehicle and it should be about 10 foot away. In reality, you're probably pushing 20 foot because you're not running straight from A to B. So you have to factor in the actual length of wire that you're using. So that's something to keep in mind. Like I said, there's charts online. Definitely check those out before you make any decisions on what size wire you need. Next thing is going to be switches. There are a ton of different switches that you can use for your different applications. Everywhere from just your basic single pole, single throw toggle switch like this. You can get switches from the OEM that have plugs already on them to plug into existing pre-wired systems, or the same similar style switches that you can have with the writing already on them for what your accessory is. You'll notice that there's multiple different terminals on the back of that. What we're going to go over today, we're just going to base off of the basic single pole, single throw switch, and that's just a on-off toggle switch. You get into switches like these, they should come with a wiring diagram, and in the drawings that I have coming up in the video here, hopefully by looking at those and explaining those drawings, then you can kind of figure it out for your switches, how to wire them up. But you start getting into switches like that and they should come with a wiring diagram. The other kind of switch, this one's kind of a little bit more unique. This is a magnetic reed switch, and how these work is you mount the actual switch on a stationary part of the vehicle, and then the other half of it is a magnet, and when the magnet gets close or moves away or anything like that, it'll open and close the switch. Those are kind of more of a specialty deal. Used to use these a lot when I did automotive security systems for pickup trucks with sliding glass windows that they wanted the alarm to trigger if the sliding glass window gets open. Those are kind of handy. But like I said, there are a ton of different style of switches available. Make sure you choose the ones that are most appropriate for your application. The next thing is relays, and what you're going to see most commonly is this style of relay right here. This is a Bosch or a Tyco style of relay. This particular one is a single pole double throw. You can tell it's got the center pin right there. That makes it a single pole double throw as opposed to a single pole single throw that doesn't have that switch. And I'll explain that a little bit later in the video. There's all sorts of different manufacturers of these. They've gotten more recently, there's, a lot of variations of these, but these are kind of the go-to for the aftermarket stuff, and that's kind of what we're focusing on here. For those of you that don't know, a relay is a switch in itself. It's just a electromechanical switch, and I'll explain that a little bit later in the video too. The main thing I see question is, when do you need to use a relay, or what's the purpose of the relay? Well, your main purpose for what we're kind of getting into with this video is current handling. You have a small switch like this. This is only rated to, maybe handle, 3 amps is what this one is rated at. But let's say you really like this switch and you want to run this style of switch, but you want it to control a light bar in a vehicle. That light bar draws 20 amps. Well, you can't just throw this switch on the hot wire of the light bar and expect that this isn't going to melt down. So what you end up doing is running this switch to control a relay that can handle the higher current output, and then you can do it safely using the switch that you want to just control the relay. Again, in the video here, I've got drawings that I've drawn up with some schematics on them to kind of show you how that works. For right now, this is what we're going to be talking about. If you have any questions or comments, feel free to put it down in the comment section below the video here. Definitely check out the channel, check out the other two videos. Hopefully they'll help you out with answering any questions on how to do this stuff yourself. And make sure you like and subscribe. So we'll get to the little slideshow I've got for you and go from there. Thanks. So in this first slide, we just have some schematical drawings. The far left there is going to be our battery. The next one over to the right from the battery, that's the schematical drawing that you'll see commonly for a fuse. Any style fuse, they all have a sign or symbol, I guess, similar to that. The next one over is your typical drawing for a single pole switch. And then the last one there on the far right is a schematic drawing for a relay. You'll see it drawn out a few different ways, but this is kind of a pretty common way of drawing it, mainly because when you actually draw your wiring connections, makes it simple. These two drawings are just your different types of schematical drawings that you'll see for both single pole, single throw, and single pole double throw relays. The top kind of represents what the pinouts look like on the actual bottom of the relay, and then the bottom is the schematical drawing of them. You'll notice that they're super similar. You just have on the single pole, single throw, it's just missing the 87A pin, but that's the only difference between the two of them. For the purposes of this video, I'm just going to go ahead and stick with the single pole double throw relay drawing. It's what I most commonly use. And again, these are just the two drawings. One is kind of represents the pinouts on the bottom of the relay. The other one is our actual schematical drawing. Probably the biggest reason people get confused with relays, I found, is that they don't actually understand what they are or what they're doing. A relay is just an electromechanical switch, which means it's a switch like any other, but instead of you physically flipping the switch and turning it on like a toggle switch, it's done electrically. It does this because it's a two-part deal. Inside the relay you have a coil, and then you have the switch itself. You'll notice in the drawings there, the part that's in the red is the coil, the part that's in the blue is the actual switch. What you actually hook up to make the relay click or turn on the switch are the wires on the coil. That's your 85 and your 86 terminals. Now on the switch side of the relay, what we have is, in the case of the single pole double throw relay, you have three terminals. You have your 30, which is common, your 87A, which is normally closed, and your 87, which is normally open. What that's referring to is in a non-energized state, as if you were to just grab it off the shelf and open it up out of the package, the common would be what you would want your final load to see, your lights or whatever it is that you want to hook up. So let's say you wanted positive 12 volts to go to your lights through that relay. Then what you would want landed on your common would be a 12 volt source, positive source. Your 87A would be normally closed, which would mean if you wanted that to be on whenever the relay was not energized, you would hook up to the normally closed. It would allow voltage to pass from that 30 to the 87A. Most of the time you're using it as a switch to turn it on, so what you would want to put the load side on would be the normally open side. So in a de-energized state, that power that's connected to your common number 30 would not pass through. But when you energize the coil and it flips the switch, then the power would go from 30 over to 87 and turn on your load. This drawing is going to depict a basic wiring diagram. If you say wanted to add a set of lights to your ATV or your truck or whatnot, and you wanted it to turn on and off with a toggle switch, let's say that switch that's in there can only handle 5 amps of current, but your lights that you want to hook up require 20 amps of current. What we got here is your battery is obviously grounded on the far left of the picture there, and then you have constant 12 volts runs to the fuse. On the other side of the fuse, you'll have 2 wires coming off. One will go to the one side of your toggle switch. The other wire will go over to your common on your relay. Off the other side of the switch, you're going to take a wire to your 85 on your relay. That'll energize the coil because, as you notice, we have a ground wire on the 86. So with the switch off, the coil is de-energized. When you turn the switch on, it will turn that relay on, and it'll click over from the 87A over to the 87, which you'll see I have marked as your positive terminal of your load. In this case, we're talking about adding lights, so that would be your lights. This will allow the lights to draw their required, like I said, let's say 20 amps of current, but you're not drawing that power through the actual switch itself. The actual current running through that switch is only the minimal amount of current needed just to trigger that relay. At this point in the wiring sequence, this will work as you would expect it to, and it would be perfectly safe. If you're running a smaller load, something like this would be just fine. And the reason I say that is because everything is going to be sized based upon not only what your end load needs, but also what size wiring you have. The whole purpose of a fuse in the system is not necessarily to protect the load, but more to protect the wiring. So any wiring that you have in this system needs to be sized based upon the size of that fuse. So if you have 20 amp fuse in there, your wiring would need to be rated for 20 amp throughout the whole system. That would be feasible in most applications. However, if you're putting on a larger load, then you're going to have larger wire, and depending on how you have everything routed in the vehicle and everything, that could add up to a big expense in order to run everything through that one fuse. Later on in the video, I'll kind of get into how we can make it so that we can run smaller wiring where we need to help save some of the cost in the end project. Quite frequently I have people ask how they can make the lights or whatever controlled not only by a switch, but only when the key is turned to the on position. That way, once you turn the key off, if you forget to turn off the toggle switch or whatever, it's not going to drain the battery. Now, if you're only adding one circuit in, say lights like this, you could tie into an existing accessory circuit and take it to the switch instead of taking the switch off of the fuse that we've added. And then you're going to have that control with the ignition, yet the lighting relay is still going to be fed from your fuse that you added in earlier in the circuit. However, if you want to add anything additional later on, it's not a bad idea to go ahead and add an actual relay for your additional accessories like we have shown in this drawing here. In this drawing, you have coming off of your existing accessory circuit in the upper left of the picture, going to a new relay that's going to that'll make that relay turn on and off with the ignition. But the power for that relay's switch portion is coming off of the fuse that we added earlier. That way, you're going to keep everything on switched power with the ignition. That works well, but there are some drawbacks to doing that. The drawback being your wiring size for everything except for that small brown wire running that accessory circuit relay up top needs to be sized according to your fuse size that you have down below in the picture. Hopefully this drawing helps kind of explain that a little bit. All of the wires that are marked with purple arrows in this setup here would need to be sized according to the size of that fuse. Reason being, if you follow the flow of current, all of these wires, the only protection for them is that fuse there. So if you're running a larger load, that could mean a lot higher expense in larger gauge wiring. There is a way that you can actually do this, though, that will help reduce the size of wire needed and therefore reducing the cost, but you're going to have to add another fuse. Alright, so if we look at what we have highlighted here in the purple circle, the yellow wires, these are the wires that you can downsize if you were to add a fuse in line. Now in the drawing here it doesn't look like it's very long run, however, unless you're running all of your wiring within a couple foot space in the vehicle, these can add up. You know, they could be 10, 15, 20 foot long. These wires, as we have it wired up here, are only going to draw the amount of current through them needed for that relay. So, if we were to add a fuse in, we could drop that down. Since we know a relay draws only around 1/4 of an amp or so, we could drop the wire size of those down significantly, but we have to protect that wire with a fuse that's appropriately sized. So that's what we're going to do here. By adding this fuse in here, we can now drop our wire size down that goes to that switch significantly and then fuse it accordingly. So you could put, in theory, a 1 amp fuse in there, and that would be sufficient to power up that one switch and relay. Keep in mind, a switch itself does not draw any power, at least for a single pole plain toggle switch. What's drawing the power is that coil and that relay, again, probably only around 1/4 of an amp or so. So you can significantly downsize the wire and thereby save yourself quite a bit of money in the wiring itself on your project. And then this drawing just shows that if you add that extra fuse in there and knock down the size of wire going to your switch, your remaining wires that are marked with purple arrows there, you'll be able to fuse those and size the wiring according to the end load, again, your lights in this instance, and save yourself a lot of cost in wiring. So these last couple of clips here that I've got are kind of just some extra stuff that I worked up because I have had some people ask for it. This is the setup that I have for my accessory fuse box and my CF Moto U-Force 1000. And there was some confusion with the last video that I did where I kind of went over that and people were a little unclear of what it was that I did. And that's mainly because I didn't actually record it while I was doing it. It was kind of an afterthought and I went through it. But this is a drawing of how I basically have it wired up in a kind of generic sense. So off of my battery, I have a 50 amp fuse, and then from that 50 amp fuse, it goes over to the common terminal of a 250 amp relay. I didn't necessarily need a 250 amp relay in there, but in case I ever want to increase the size of it later on, then I've got it there in place. The relay is triggered by an existing accessory circuit, which we've already talked about before in the video. Personally, I hooked mine up to the winch relays. I had to run some other wire in that general direction anyway for something else I was working on the machine, so I just hooked up to that. There are other closer accessory wires in there. That then makes it so when you turn on the ignition, it triggers that 250 amp relay and allows the power to flow from the battery through the relay to a distribution box that I have mounted up front under the hood of the machine. The distribution box is there simply as a convenient way to transfer from the larger gauge wire that I ran for the 50 amp feed to break it off into individual circuits to the 6-position fuse box, relay box combo deal that I have up there right next to it. That's the main purpose for it. Now, we've talked about fusing, so I want to make sure I'm clear with this. Those wires that are coming off of the distribution box, those 6 smaller wires, those are not rated for 50 amp, but they are only about 8 inches long. No chance of them really getting damaged by anything, so they are fine to be unfused for that small 8-inch portion there. The drawing it's all out of proportion, so it doesn't really, it looks like it's a longer distance than it really is. So, but if you want to check it out, go check out the other video on the channel there, and we will move along here. So on this drawing, if we this blows it up a little bit and makes it a little easier to draw it out so you can see what's going on. Up in the upper right hand corner, we have our 6 wires that come off that distribution box, and they run to one side of the fuses, down the one side of the fuse block. Now, I've got 2 spare fuses in there, the ones down on the bottom, that I don't have any particular use for at this time. I'm just using the top 4. The top one is fused at 10 amps, and it runs basically in a couple different directions here. It runs back inside the cab of the vehicle and feeds the power for all 3 of my switches that I added for a light bar, fog lights, and spotlights, as well as, since if you follow the diagram, those 3 switches are only controlling relays, so again, pretty much almost next to no current draw. It also feeds the accessory power for my sound bar that I have, so that the sound bar knows to turn on and off with the ignition. Now, the rest of it, I'm not going to go through step by step, but you can take a look at it here. The arrows kind of show the flow of electricity and how it all goes through. The individual fuses there are fusing the loads that for the lights themselves, and the switches are all on that first circuit, so they're kind of divided up. Hopefully this helps clear up some things, because I've gotten a lot of messages from people, not necessarily in the comments of the video, but a lot of messages from people asking how it was that I wired this up. This is about as simple as I can make it. I hope this helps you guys out. If you guys have any questions, drop them down in the comments. Alright guys, I hope that helped you out a little bit and helped to kind of explain how things work a little bit. I've gotten a lot of questions on how I added my accessory fuse box in my side-by-side, and it's kind of hard to explain through private messaging and whatnot, so that's kind of why I threw that little bit in at the end. Hopefully that also helped to clarify some questions that you might have had. Again, thanks for watching. Make sure you check out the first 2 videos of this little series, and check out the other videos on the channel too. They might not pertain directly to what you're interested in, but there might be some stuff on there that could help you out with some of your other projects. Don't forget, like and subscribe, and if you have any questions or comments, drop them down below. Thanks for watching, guys.